video is on the acids and bases, and it's going to be on understanding pH. So pH is a logarithmic measure for the concentration of hydrogen ions present in a solution. In an exam though, when they ask for the definition, well, it's defined by pH equals minus log H plus, where H plus in square brackets is a concentration of hydrogen ions in moles per decimeter cubed. So just a quick example just to use this in principle. The concentration of hydrogen ions in a solution was 6.9 times 10 to the minus 8 moles per decimeter cubed. Find its pH. So what we do is we know that pH equals minus log base 10 to the hydrogen ions. So all we need to do is sub in our concentration of hydrogen ions. And in terms of log base 10, that's just your normal log, it's the standard used, so just don't really worry too much about that. But then, if we sub this in, the answer we should get is 7.16, and if you just try that now on your calculator, you should see how this works. So, moving on, we should know this from GCSE, but when pH is low, so for example pH 0, the solution is acidic, so in this case it's very acidic. A pH of 7 is neutral, and a pH of 14 is very alkaline or very basic. What we also need to know is how to work backwards from using pH. So how to find the concentration of hydrogen ions from pH. And to do this we use the inverse of log, and that's 10 to the power, and to find the hydrogen ions we use 10 to the power of pH minus, and this gives us our concentration of hydrogen ions. So it's easier again to do a calculation visually. So a strongly acidic solution has a pH of 0.4. Find its hydrogen ion concentration. So using the equation that we know here, we just sub in the minus pH, so the minus 0.4, and this will give us an overall answer for our hydrogen ions of 0.398 moles per decimeter cubed. And if you're unsure of how to get that 10 to the power, just do shift log on a Casio and you'll get it. Other brands you'll have to ask your teacher. So moving on, we need to know about strong acids again, and this is just recapping from my last video, but strong acids almost completely dissociate into their ions. What this means though in terms of pH calculations is the concentration of hydrogen ions is exactly proportional to the concentration of the initial acid. And there are two types of acid though that we need to know about, and these are strong acids, let me just make clear. And these are monoprotic acids, which release 1 mole of protons per mole of acid associated, and an example is hydrochloric acid, where as you can see here, hydrochloric acid breaks up into 1 mole of protons, 1 mole of hydrogen ions, and 1 mole of chloride. So obviously because of the 1-to-1 ratio, the concentrations of these will be the same. Furthermore, diprotic acids release 2 moles of protons per mole of acid associated, and I'm sure you would have already figured out by now, the example will be sulfuric acid. So for example H2SO4 will break up into 2 moles of protons and 1 mole of the sulfate ion. So the ratio for this is 2 to 1. So obviously we've got 2 moles of the acid, so 2 times the concentration. So when calculating things like these, it's easy to just, well, it's quite an easy calculation. So for example, to calculate the pH of a 0.25 mole per decimeter cubed solution of hydrochloric acid, what we just need to remember is hydrochloric acid is a strong monoprotic acid, so that means that the concentration of the acid will be equal to the concentration of the hydrogen ions. Then we just sub in this concentration then into our equation for pH, and if you do this on your calculator you should get a value of 0.6 for your pH. So that's it for the basics of pH and how to solve strong acid questions. It does get a lot harder than this, but not too hard with enough practice. So I hope that helped, and well, I'll see you next time.